Welcome back, class, and thank you so much for joining me. So today we're going to move on. So remember I said trigonometry is talking about right triangles. Well, today we're going to move on from that. So we're going to start investigating what do we do when things are not right triangles. Now, before we move on, I do want to just review really quickly what it means to use those trig functions in right triangles. Just really basic review. So in this first one, what I see is I have the adjacent side and the hypotenuse to that angle. So that is telling me I'm dealing with a cosine trig ratio. So the cosine of 46 degrees is adjacent, which is 5, over the hypotenuse, which is x. So if I want x by itself, first thing I have to do, multiply that x over. Well, now I still don't quite have x by itself. Now I'm going to have to divide by that cosine of 46. So x is going to be 5 divided by the cosine of 46 degrees. From here, all you have to do is punch that into your calculator. So 5 divided by the cosine of 46, and that gives you x is about 7.2. Now we can also use trigonometry to find the angles. So here I see adjacent and opposite. So that's telling me I'm going to be using a tangent function. So tangent of theta is opposite over adjacent. Now remember, when I'm looking for an angle, I need to use the inverse trig ratio. So remember here to find the angle, I use that inverse tan button on that 10/3. So inverse tan of 10/3, that gives me about 73.3 degrees. All right, so again, just a really quick review of the basics so you remember how to deal with right triangles. But again, today our focus is shifting to things that are not right triangles. There's two rules we can use. Today we're going to focus on the law of sines. That's going to be the first rule because quite honestly, it's just easier to use. Now, law of sine. In any triangle, the ratio of the sine of each angle to its opposite side is constant. In particular, for this one, for triangle ABC, you can see what happens here. So the sine of A divided by side length A is the same as the sine of B divided by the side length B, which is the same as the sine of angle C divided by side length C. Their ratio is constant. So basically what you're going to do is you're going to set up a ratio. Now you're ever only going to use two of these at a time, okay? You're never going to set up a ratio of all three. You're just going to have a ratio of two of those sit equal to each other. Now, basically, this works whenever you can create a side and an angle pair within a triangle. And I'll show you what I mean by that in just a second. But if you're looking for kind of concrete rules, first rule, you can use this when you're given any two angles and a side length. So we're talking about two cases here. Angle, angle, side, and angle, side, angle. Now again, I'm not going to go deep into what those mean because hopefully from geometry you remember all those triangle cases. But you can do it again when you have any two sides or any two angles and a side. You can also do it when you have two sides and one of their opposite angles. So side, side, angle. And again, in this you must have a side and an angle pair. You must have a complete pair in order to set up that ratio. Do want to caution you though, be aware, we're not going to really touch much on this class, but if you continue on into college algebra or pre-calc, this second one does lead to what's known as an ambiguous case. Because if you're given an angle and a side, this other side, this can create two separate triangles using the same length there. You could create this big triangle here using those dimensions, or you could end up with this smaller triangle. That, again, is known as the ambiguous case. Now, for the sake of the ACT and the sake of this class, we're not really going to be too concerned about that ambiguous case, but just realize that it is possible. It could happen. Okay? Now, what you're looking for, the concretes. How do I actually use this rule? All right, so law of sines to find each of the following. Now, again, the first important thing is we need to set up an angle side pair. All right, so looking at this first one, I need an angle side pair. Now, what I see is I see this 3 and that 27. That's an angle side pair, an angle on the side that is opposite from it. So I'm going to set that up. 3 over the sine of 27 degrees. Sorry guys. Equals, well, now I have this other pair, A and 54. So equals A over sine of 54 degrees. So again, the key though is you have to be able to set up that first ratio. You have to set up a complete ratio here. And then in the second one, you'll include whatever you're missing, whatever you're trying to solve for. So now I'm trying to get side length A. So I need to get that A by itself. Well, right now that A is being divided by the sine of 54 degrees. So what I'm going to end up doing, I have to multiply by that sine of 54 degrees. So I multiply that over. So I have 3 sine of 54 degrees over sine of 27 degrees equals my A. Now, don't try to do any simplification here, okay? Because if you try, sines, cosines, and tangents don't simplify with any fancy rules like you're thinking. So you legitimately have to type that monster into your calculator, all right? So again, don't try any shortcuts. Just what I have written there, type into the calculator to get your answer. So 3 sine of 54 degrees divided by sine of 27 degrees. And you should be getting side length A is about 5.35. All right. So again, it's really not too horrible or too difficult, okay? It's just getting it set up and then using it. Now, looking at this next one. So, I have my angle side pair. I see this 3.2 and this 22 degrees. So I'm going to set that up. 3.2 over sine of 22 degrees. So I first set up the pair that I know, and now I'm going to set up my other pair. So I have my C here, but I don't have angle C. Now you may be thinking, hey, that's a problem because I need that. Well, interestingly enough, it's actually okay that you don't have that because I want you to see what happens here. I know 2 angles out of the 3. So we know a property about triangles that can help us. In every triangle, those angles have to add up to 180 degrees. So if I know 2 of those angles, I can subtract both of them off from 180 and get the angle C is 108 degrees. Now that I have that, now I can finish with that. All right? So again, goal here is remembering that if you have 2 angles, you can find the third angle automatically, and you can use that to complete what you need to find. So I have the setup now, and I'm trying to find C. So I'm going to multiply that sine of 108 degrees over. So I have 3.2 sine of 108 degrees over sine of 22 degrees equals my C. And now again, just type that in just as you see it into the calculator, and it will give you the right answer. 3.2 sine 108 divided by sine of 22, and that is giving me about 8.12 for that side length C. All right, moving right along. So in this one, we're looking for the angle. So these next two are going to be the opposite of what we've been doing so far. We're going to be looking for the angle. Now, when we're looking for the angle, I'm going to have the angles on top of my ratio. Okay, so notice on the first two, I had my side length as the top of my ratio because I was looking for side length. Well, now I'm going to have the angle on top of my ratio because I'm looking for an angle. Which angle am I looking for? Well, I'm looking for this one right here. But first, I'm going to put my complete one here. So sine of 77 degrees over 9 equals, now I'm going to put the one that I don't know, so sine of C over 6. All right, so need to get C by itself. For the first thing is that sine of C is being divided by 6. So the first thing I'm going to do is I'm going to multiply that 6 over. So 6 sine of 77 degrees over 9 equals the sine of C. All right, and now to get rid of that sine, to find that actual angle C, remember this is where we're going to use that inverse sine. So I'm going to inverse sine that entire side of my equation. So you have to inverse sine that whole thing. If you're careful, you can type this in all at once. You're just going to have to be very careful with how you use parentheses. So inverse sine of 6 sine 77 divided by 9. So again, just make sure you're using parentheses carefully, and you will get 40.5 degrees. So again, I would urge you to specifically try these two with me because they're just a little bit trickier on the calculator. Completely doable, just a little bit trickier. One extra step we have to take in doing that inverse sine. All right, let's set up our next one, shall we? So this time again, I'm looking for an angle. Now let's go up and see. I'm looking for angle X. So I want that angle right there. So, all right, so looking for X. Now, when you go to set this up, you may start noticing something a little bit tricky. So, the complete set that I have those two. So, sine of 108 over 11.7. But now when I go to set up my other one, you may notice I don't have the side opposite of X. I have the side that's opposite of Z. So this is a little bit of a problem because we can't directly find X that way. I can find Z. Now, that's still going to be useful to us in the end though. So let me show you why Z is still going to be useful. So, if I find the sine of Z over that side opposite of it, which is 5.6, when I have that construct, I'm going to do the same thing I did before. All right, I'm going to multiply that 5.6 over. I'm going to inverse sine it so I can actually get what that angle is. Because remember, whenever you're looking for an angle, you should know to inverse sine. All right, so let me type that into my calculator. So inverse sine of 5.6 times the sine of 108 divided by 11.7, I get 27.1 degrees. Now again, you may be wondering, how is that helpful to me? Why can I use that? Well, now don't I know two angles in my triangle? And once you know two angles, you can always automatically figure out the third. So that's the key to this, all right? Is I can still use that, and I can subtract both of those off from 180. And that'll give me my final angle x, which is going to be 44.9 degrees. All right, so again, that one's a little bit trickier, however, still doable, because as long as you know that all the angles add up to 180, you should be able to get it. All right, so let's jump to our last problem, our word problem. An observer is near a river and wants to calculate the distance across the river. He measures the angle between his observations of 2 points on the shore, one on his side and one directly opposite on the other side, to be 28 degrees. So before I keep reading, I'm going to draw the situation. So I have this river here, okay? And I have this guy standing here, and he is making two observations, one on his side of the shore and one directly opposite. All right, so that's what my picture is going to look like. And so far what I'm being told is the angle between those observations, so this angle right here, I'm being told that's 28 degrees. The distance between him and the point on his side of the river is 300 feet. The angle formed by him, the point on his side, and the point opposite him is 128 degrees. What is the distance across the river? So we want to know what that is right there. That distance across the river. All right. So, in order to figure this out, we need to find a complete angle side pair, right? We want to use law of cosines, but right now you may notice we don't have the angle opposite that 300 feet. Well, again, we should be able to get it though because we have two angles. So let's figure out that third one. And again, all you're ever doing to figure that out is taking 180 degrees, minusing off the ones that you know. So 180 minus 128 minus 28. That leaves this angle here to be 24 degrees. All right, so now I have that complete set to use. Now looking for a side length, so I'm going to be putting the side lengths on top. So I'm going to use that pair that I just found. Again, you always need a complete pair. And I'm going to set that equal to x over its angle. And now, algebraically, I just have to multiply by that sine of 28. Divided by sine of 24 degrees to get the x by itself. And again, don't do anything fancy, just type this into the calculator as is. So 300 sine of 28 degrees divided by sine of 24 degrees. And I'm getting that that river is 346.3 feet across. All right, so another one of those lessons. I apologize it got so long, a lot to take in. However, very good material and I think completely doable material as long as you have everything written down that I just did on the board. So again, please make sure write everything down, come back to class prepared to do some more practice work on this.